Alright, so I forgot to record last week. Crazy. Spoilers, I did some debugging. WFlash was not working. Let's try what's happening. I guess it does have to work. Okay. This should be working like this bit. It's not segfolding, so I don't think it's these. Acceleration, I think I tested all three. It should be fine. Let me check. Include /whfast.hpp. Okay. Q. Wait, no, that was not. That was just integer.hpp. Yeah, I have bad memory. Okay, now, gravity is basic. That's expected, and that shouldn't be an issue. Okay. I'm not sure what's going on then. Okay, so basic's the default. Not sure what the issue is. Let's just. Okay. And I tested that with all other ones. The acceleration's fine. I don't know why. Yes, I did some good old AI debugging. I know. Illegal. So what's the issue here? Let's see. Update Excel epsilon 2 and let me say epsilon. Okay, I think epsilon's twice. Okay, I'm making sure. Okay, here. The pragma won't be parallel for. It can't possibly mean if there's a corruption before the transform. It's really because the reciprocal test I did should not have. If the reverse step would just nan everything back, it's not gonna get rid of those nans. So that's definitely not the issue. Let's see. dr star particles and times this. Okay, so dr. Not sure what's happening. It just act as if this is not an issue. Okay. Not sure why this is the case, but let's see. Anyway, okay. So, does the WHFast integrator require the star be at 0, 0, 0? Okay. So if I go into here, paste this, and if I go into here, yeah, this is nanning for some reason. All the gravity methods work. Don't nan, and yeah, I did check transforms beforehand. They work. Transform had been tested long ago. Yeah. Okay. This is interesting. Okay. The pre-drift update velocity. Last I checked, the particle isn't on top of a star. Let me check, I guess. Okay. Okay, let's not print this guy here. This here is gonna be unnecessary, and I think I can get rid of this. Okay. If standard, too much rust, bro. Standard is nan particle dot velocity index I printf us bad. Okay, what is it, bro? No matching. Should call okay, let's okay, alright, okay, I forgot this though. If an article's dot velocity index I equals not a number, if a standard is nan, how to check if a number is nan or infinity. C++ is inf. Okay. So this would be, is inf return 0? Oh. If standard is inf particle dot velocities index I, or standard is nan C++. Is nan is okay, what is this? Okay, where are you? Hello, nan. Okay, I know it's very rare I do this, but yeah, just guess a good it is nan, and that's velocities index I. Oh, I don't know what kind of drugs this thing is supposed to be on. Isn't C math already implicitly? Yeah. Okay, so now if I test this, which I in my build that I say cell script, no matching function call, float. Okay, that explains some. I'm just stupid. This is all vectors. This is I think I have this. Do I have a utility function for this? I'm gonna check real quick. So, if particles of velocities index I dot is dot mag equals 0, printf bad. Okay, let's just try this. If there's any nan in there, it's going to be revealed in this. So, okay, so now let's run this build script real quick, and that I knew that would fail, but let's just now go into bad, and now there should be a bad, I don't know. Bad, okay. So I know another C/. Let's go debug this again. Okay. Where are you? Bad. Printf bad new line, and not sure there are only 2 bads. I haven't checked the test script for this. Have I? Yeah, I haven't. Let's see. Yeah, so the magnitude is indeed nan. Not sure where that came from. Okay, though, I think update Excel means particles, and it should be editing particles. I don't think it's some dummy data is in there. Now let's edit this, and let's say, let's just add the correction equals, and I guess we grab this monstrosity. It's star pod minus this. That shouldn't be an issue. That's definitely not an issue. I'm not sure what's happening. Let's try this. DT is definitely fine though. Let's just grab this, paste it here, and now if I print f def d percent d new line. Okay, so if I get rid of this print too. Let's clean this up. Here we should do dash n and then correction.x, and you just do this. Okay, what is it? A format specifies int. Oh, not sure how I'm supposed to specify it. How to specify double in printf. F. Okay, interesting. Not sure D isn't that, but I guess it's fine. Okay. If I build this now and run this. Okay. These guys are actually fine at first. That's surprising. That's just and if I, but everything else is an and. Corrections are doing interesting corrections. Okay, let me clean my stuff. Okay, now if I go into here, yeah, everything is nan, which is, I don't like that. These first two aren't nan though. Interesting. This is a weird case of a bug that I don't understand. Yet it somehow manages to survive. Yeah, okay, I think there shouldn't be any nans left over here, which, let's test it afterwards. Let's just grab this line and let's grab this. Yeah, I think these are some decent lines. So now let's grab this. Cool. And now I have to actually save it now. And let's run the testing. Okay, I think testing is doing something interesting. Okay, let's debug. So you should be here, and there should be two prints. There should be two prints. Where'd the two prints go? Hello? Where are the two prints? Also, what's happening with the star? That is a thing I need to know. What is happening with the star? I think it should be getting pulled around or something. Not sure what's happening to it. Doing quick debugging. Now if I get rid of these lines for now. Okay. Let's see now. And this. Okay, so now let's update this. Anyway, in the WH-Fast integrator, what happens to the star itself? Yes. Okay. Yeah, okay, so good. And now so this line not perfectly synchronized. Wait, let me open the test first. I open the test first. Want to check. Yeah, this should be fine. This is not fine. And there should be 3 particles. There should be only 3 particles. Not sure where the rest went. And I'm asking questions. Yeah. Not sure where the rest went. And I do not know why this happened. Okay, yep. This C math, MPy time MPy just does not look like anything weird's happening. Okay. 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 Right. Okay, so let's see. Okay, I don't see any bugs in it, and my test code has the planets yet nowhere near to the star. Okay, so here. Yep, so T over R and mu squared over mu. This is interesting. Okay. Okay, here is this. For int I equals 0. And now if I go there and just walk. Okay, where is this? This I just in 10 loop. Okay, so I'll just put this in. And so now if I do this. Wait, no, I have to build this thing first. And this time, run it. Alpha is non-finite. Let me count these lines though. That is something I need to know. Okay, it's because if it did that, let's paste that into Vim. Never mind, NeoVim. Okay, that has 78. I mean, what could that result in? Like, right, 78 divided by 2 is 39. 9. Okay, so the first iteration did not screw anything up. Okay, good. Just cube. Just cube. I don't want anything. Okay. Now if I let's go into the test real quick. Slash. Okay, so here we're doing one year. I think this is a solar mass entire year. This was the test code. Yeah. Okay. Relative to the berry center is an ID and 2 planets. Order is iterates in the order of where in the logic of the code did it say have anything related to the ID? Okay. Not sure why it's doing that. The fatal unphysical state. Okay, yep. As a basic thing, it seems the first step is fine. Anything after is broken. Is all nans. No, I actually have a genius idea here. Let's run this once. If this thing passes, I think it's just some weird. Nope. Okay, that failed. Okay, what is it? Nan versus that. Okay, no, so it only print. Okay, so it's still nan after the single first step. It just doesn't print anything or any weird alpha issues. Okay, that explains. That's kind of annoying. Okay, let's get rid of this. Now, if that's an error. First, if this thing doesn't crash at NAND, which I really hate, why does everything complicated in orbital mechanics just tell you to do NANDs? This is annoying. So C is this, S is this. Okay. I'll just paste this. And just give me the exact issue. And then you send this. Okay. Okay, here. Correct this line to this. Okay. T times alpha. Instead of alpha, I should place it with this. Okay, that's okay, interesting. And if I go ahead and grab the initial guess and just do this. In this kick step, you have this. it happens to be very close. But a precision errors. If there's not a precision error, that is just a straight up, like, math issue. That's not a precision error, Gemini. Okay, dekai update, no safety check. And damn it, and not sure what. Okay. Okay, let's try again with WQ. If I run this, fail, and if I run this, nan. Yay. That did not help. WHS.cpp. So now, let's try to find have to check if I run this. It happens near the periapsis, which, good point. And if I run this too, wherever that's supposed to be, it's in dekai. So now let's fix this. Here, I've quit now, and now let's run this, and nan again. Both of them. It's still NAND. NAND, they're both. Is that semicolon method or the Podula catches the exact state causing the NAND? Okay. Okay, so I type this. Let's copy this. And that's all I do. And src says storagefast.cpp. And here, I think we can, and this is of note, right here, we should be able to just grabbing, paste this, get rid of these lines, get rid of these comments, they're annoying. And let's see. Charlotte, I'll do something. I mean, I'm not excited. If it did break, it's still gonna say fail because I ran it on, and of course it's on AND still. Okay, PJ being fully reset or cleared. Oh, wait, no, it failed after each step. And your updated formulae still cause a NAND. I do not like debugging, to say this least. This surely will fit. Relative to positions, you don't adjust star pause or the com shift. Okay, the R value is measuring distance to the berry center, but your gravity kick is measuring distance from the star. Okay, interesting. Okay, so I should probably have set it to the relative positions, the column shift. Okay, here, z is a very large number for plus n. Okay, so let's check some CS. Might have something in there that I need to fix. CS if n plus n. So n while this is greater than 4, you do this. Okay, average stuff. This is math, as is. Okay, so the pj.positions.mag. Okay. Star pause in the barycentric. Did I use star pause in this earlier ones? I think. Did I use it in the earlier ones? pj.velocities index I. Yeah. pj.velocities index I equals this. And here, this is just a standard. Yup. Not sure. And everything here is done after transform Jacobi. I think there are issues. Okay. So CS6 and CS alpha times chi C equals CS index 0, so it's index 1. 1 minus chi times chi divided by R times C. Pj dot is index I equals F dot times old P plus G dot times old V. Okay, and interior mu plus equals particle dot mu. Okay. Interior mu. Square root interior mu. dt 1.0 fast tabs. dr.mag. dt by 2. Okay, this is... I don't see any obvious issues. I don't see any. Granted, they're probably tiny issues, and those are probably the issues. Okay. Try this diagnostic step. Okay, I'm not using star pause anywhere else. Okay, so now I should probably set star pause to something else here. Let's try this. Star pause equals particles dot positions index 0. Star mu can stay the same. I last checked, these integrators don't exactly change the mass of objects. Let's try this again. And now this probably should be a major fix. It fails as is standard, and it nans. Okay. Indeed. Let's see. This is going to immediately this is going to immediately nan. This is immediately nanning, which is not much of an issue if you find a non-functional integrator. Okay. See. Right. Okay. So that was probably some small numerical error that would have not caused nans, but that not fixing said nan, but it probably would have fixed any subtle numerical bug I added. That definitely did not fix anything, though, as far as this is concerned. Okay. Before the Kepler loop, critical collision or transform failure. Particle at com. Okay. Interesting. R is less than 1e minus 9. Okay. Explicitly ensure alpha. Calculation to be more robust. clamp alpha to avoid this interesting okay, hear me out on this idea. Let's try the logical solution, aka deleting the whole thing. So pj.positionsindex_i equals old p. Okay, so let's try. pj.positionindex_i equals old p, and it's probably gonna use the unused variable, which p, and now old p, and if I go dot, it's all just old v now. Okay, cool. So if I go into here, build.sh that, if it's, I know it's not gonna pass. Okay, yep, and it's also nah. Can't tell. Can't really tell, but like src slash right, wfast.cpp. If I go in here and just decide that this entire loop is, useless, go in here and decide that this entire loop is useless, like, if I go into here and delete that, and no, let's grab it and build that now, and if I run this, it nans. Okay, can't. Jacoby Bell, did I have some pasting errors in there? I did some testing. Okay, so now it's a nothing integrator, I guess, but it's not actually integrating anything, I know, but it does not really help. Does not help much. So, like, I think this is fine. :q. If I do .build.sh, then .build/whfast. So this is nan, which, again, I don't know why it's the case. It's a nan. That is something I need to determine quite rapidly. Okay, let's test this on. Okay, my Jacoby transform test. nvim unit tests / Jacoby transform test.cpp. Well, now if I inertial to Jacoby pause, Jacoby val, and we do the same thing over here. Jacoby to inertial and Jacoby to inertial. And if I .build.sh. Okay, so the reciprocal test is fine. And Jacoby transform test worked, so like, not sure what's going on. At the same time though, like if I do an actual test against particles, granted did I use a proper test for this? Yep, I just added random particles. I actually did add random particles. Good. Just doing. Then let's just see. Right, so that's clearly it's working. Let's debug each part of this. correction should be this. Update Excel. Come on. Init dummy store. You mean update Excel? Hello? Yeah, you need to update your acceleration. Is that the issue? Like, let's just print F and def new line and particles.accelerations index I dot x particles.acceleration index I dot y and particles.accelerations index I dot z. Okay, let's try this. Dot slash dot sh, and if I run that file, -39 and -17. Okay, this is fine. This is fine. Not sure what the issue is. So let's just go ahead and grab the acceleration is fine. And obviously once everything lands, that's gonna cause an acceleration issue. So I don't think that's an issue. Let's just debug this now. dr.z this time. Now let's run this. And it's -1 and -1.5. These are fine. These aren't causing issues. Let's see. Both of these are not an issue. Not sure what the issue is. That's an issue. If I go ahead and run this, so it is times dr over dr.mag, dr.mag not 0, times particles accelerations. Yeah, at this point, this is fine. This bit's fine. Yeah, let's see. WQ. If I run this, if I get rid of those, if I get rid of the transforms, it works. But but somehow it managed to not. Man, okay, so it's clearly the transforms that are doing the thing. The transforms are something weird. Okay, let's try transform inertial to Jacobi pause. Let's just try this. Basic. So it would be particles, and then we take PJ. And then we do the exact opposite back. So transform Jacobi to inertial pause. PJ. Oh my god. I think I was being an idiot when I did that, but on second thought, idiocy is called weak. Idiocy. Okay, that was not an issue. So now let's add velocity in there too. So transform inertial to Jacobi val, or no, I have a great solution. Quit, I don't care. How to revert to current commit and get to latest commit. Okay. how to get rid of staged, how to get rid of local changes before staging. Git checkout. Git checkout. So we git checkout. Okay. Yep, that is indeed standard. Okay. And vim src says whs.cpp, and let's go into there, and I guess I'm gonna manually do this. Transform inertial to Jacobi vel with particles and PJ. Do a very similar thing at the bottom. Transform Jacobi to inertial vel PJ particles. Okay, so now if I fix that, and if I run build.sh, I swapped the parameters because in the back transform, that fixed it. I also got rid of the thing. I forgot what it was called. I got rid of the Kepler stepper, so get that back. So give me that back. Give me the original back. Okay. Okay, yep. Oh, anyway. Okay, so if I grab this, I'm just gonna grab this entire thing here, which should be good, and paste nvim src slash whfast.cpp, going down here and tab. Okay. Okay. This looks good. I think this is good. If I run this, build.sh. Okay, let's check. Yeah, well, I don't know why it just decided to pass, but that's probably some issue. Okay. What was the test? Please give me the test, I'm guessing. Anyway, src.whfast.cpp. I should probably get rid of the print now. Let's get rid of this annoying print. And now if I do this, okay, so now src slash unit tests slash whfast.cpp. Okay, so yeah, that should have worked actually, yeah. And so now let's run this 40 times for once. And okay, so now, yay, okay, so yeah, so not sure why it doesn't just print. Okay, yep, whfast, at least basic whfast does work. And so now, okay, let me get commit-am. Stupid me forgot that in the Jacobi to inertial, it should have just inertial. I swapped the parameters. Git commit, git add dot, and git commit -am. Git dash. No, I am not Googling. Googling how to merge commits. And now git push, git push, git push. All life is good. So now if let's actually build.sh, all that is running fine. Full log is worth 10 years. Yeah, logging. Again. Now that that is fixed, you know what? Now that that is fixed, I am now trying to do the corrector. Do the things WH fast rebound implementation does. Yeah, I'm asking AI for this stuff. I'm not just implementation does like the giant corrector table I have up top that I have not used yet. Okay. At least the last. So you need to keep a previous BIJ. High pressure. Yeah, I think okay, so let's make it like, actually, you know what? I've had this issue for far too long and it kind of works actually now. It actually works. So like, good. I'm not gonna bother with more. I'm gonna end the video now. Next video, we'll be covering more advanced stuff.